In this lesson, we are going to be taking a look at solving systems using a different method that we haven't learned yet, called substitution. Previously, you've learned how to solve systems using graphing. Today, we're going to focus on this new method. In order to solve any system, we must find all coordinate pairs x, y that satisfy both equations, or as we have learned before, make both equations true. You have already learned how to solve a system of equations graphically. We now explore the first way to do this algebraically, by substitution. This method relies on a very important principle. The principle is the substitution property of equality. Equals may be substituted for equals, or one equal quantity may replace another in an equation. This may not make a lot of sense to you right now, but we're going to do some practice so you can see what it actually means. Consider the system of equations given to the right. Y equals 2x minus 1, and y equals negative x plus 5. We've solved this system before graphically, so we're going to show you how to do this method again, just so everybody is comfortable and understands the connection between substitution. To solve this graphically, we take each equation and we graph it on the x and y axis. So remember, when we do that, we use the form y equals mx plus b, where m is the slope and b is your y-intercept. So in the first equation, my y-intercept is negative 1, so I'm going to put a dot at negative 1. And my slope is 2, which means I go up 2 from my y-intercept, 1, 2 over 1, because 2 divided by 1 is 2. Up 2 over 1, up 2 over 1. I also can go backwards, I'm going to go down 2 into the left 1. And then using a ruler, I'm going to connect those points so I can see my line that I have just graphed. I'm going to do the same thing with the other equation. This is my y-intercept at 5. This time the slope is negative, so that means I go down first. So I'm going to go down 1 over 1. We can't see the 1, but normally there's a 1 in front of an x that's imaginary, because 1 times x is the same number, so we don't really write that 1. So I'm going to keep going down 1 over 1, down 1 over 1, and I can see already where these 2 points intersected. Now that you've found the intersection point, you can tell me the coordinates, which are 2, 3. So x equals 2 and y equals 3. That's where the two lines intersect. Let's try doing this now using a different method, which is substitution. And remember, substitution means that you're going to replace something. So let's write down our equation. Y equals 2x minus 1. And y equals negative x plus 5. Now take a look. If you see, each equation starts with y equals. So it's saying the value of y equals this whole thing that I put in the box, and the value of y equals this. So by the property of substitution, I can make these two things, these two values, equal to each other because they're replacing the y's. That's what substitution means, you're replacing. So I'm going to say 2x minus 1 equals negative x plus 5. And now, since I have this, I can solve for x. I will add x to both sides. I don't like seeing negatives, so I'm just going to take care of that. So I get 3x minus 1 equals 5. Add 1 to both sides. 3x equals 6. Divide by 3. X equals 2. Which is the same answer that we got up here. I can then take my x equals 2 and plug it into either equation to find y. So I'm going to draw a little line to separate it. Let me shift the camera over so you can see. I have y equals 2x minus 1. I'll do the first equation. If I plug in 2 for x and now solve, I get my same values that I got above. So either method you could have used to get to the same answer. This is a different method that in certain cases makes more sense, and we'll see that on the next page. So we look at exercise 2. It's very similar to the problems that we just did. It says find the intersection point of the two lines whose equations are given below. Only an algebraic solution is acceptable. So this one says you can't graph it. So if you take a look, we're saying y equals this guy and y equals that guy. So if y equals both of those things, then those two things should equal each other because they each equal to y. So I set up my equation. This is why we use pencil. If you make a mistake, you can easily fix it. And again, you can solve in any order you want. I'm going to start with the x's. I like trying to get the x's together first. So I'm going to bring the x's over here by subtracting 3x. I get 5x minus 12 equals 23. I'm going to add 12 to both sides. 5x equals 35. And then divide by 5. X equals 7. Now that you know what x is, you have to plug it back in, and you pick either one, and you'll get the answer. So if I do y equals 8x minus 12, and I plug in 7 for x, I get y equals 44. That number seems kind of high to me, so I'm just going to check. I'm going to do the other equation as well just to prove to you guys that you can do either one. I'm going to do 3x plus 23. If I plug in 7 for x again, I should get the same answer if I did this correct. And once you plug in the numbers, you'll see you do get the same answer. So the coordinates here are 7, 44. Some other types of problems you'll see using substitution look like this. It says the method of substitution is particularly useful in solving systems when one of the original equations is solved for x or solved for y. So what that means is that one of the equations has x equal to something or y equal to something. And then you can just easily plug that into the other equation. So if we take a look at this example, it says solve the following system by substitution. Looking at the two equations, one equation has a variable that's solved for. That's the second equation because x is by itself. It says x equals, so this means I can put the box around the 2y minus x. The benefit of this is that what I can do now is replace the x in the other equation with this value because this is what x is equal to. So this is going to go into the x place and I'm going to solve for y. So let's do that. This box is replacing the x. I'm doing 2 parentheses 2y minus 6 plus 3y equals 16. Let me write down 2x plus 3y on top of it just so we can see the original equation. So notice all I've done is I've substituted, I've replaced x with the 2y minus 6. And now you have to use your knowledge of algebra. You distribute because you've got parentheses with a number on the outside. So 2 times 2 is 4y with the y there. 2 times negative 6 is negative 12. Combine like terms, I can see 4y and 3y make 7y. Add 12 to both sides. 7y equals 28. And then divide by 7, y equals 4. So what's really nice about this method then is that I can take that answer and plug it into this part right here because it's going to tell me what x equals. X equals 2y minus 6. I plug in 4. 2 times 4 minus 6. 8 minus 6. X is 2. And so then I have my answers. Let's try one more example. In this problem, solve it by using substitution. My y value is the one that's solved for. The y is by itself. So I'm going to plug in this value for y into the other equation. So this is going into the value into the other equation. So I have 4x minus y equals negative 12. Take my y value, plug it in. Notice there's a minus sign on the front, so I had to put parentheses around it because the minus sign is going to change things. So I'm distributing a negative. 4 take away 1 is 3, so that means 3x's minus 9 equals negative 12. I add 9 to both sides. 3x equals negative 3 divided by 3, x equals negative 1. Now I can plug that into the other equation. Y equals x plus 9. I know x is negative 1. So y equals 8. And there's my solution. Try the bottom two problems on your own. Determine which method is better for solving using graphing or substitution. You do not actually have to solve the problems. Just try identifying what method is best. Once you've completed that, then you can start working on your homework for this unit.